So, good afternoon, students, one and all. So, this is classroom discussion topic 3 on VLSI design styles and physical optimizations. So, in VLSI design styles, we are the first one we to discuss is layout editor. If you see this particular layout editor, you will have the menu bar, toolbar. This is the drawing tool. The first advancement in the layout tool is you can able to change the colors for your metals, and the mouse buttons means you can switch to the different types of applications. Means you can first view the metal, or you can view the only the wiring part, or you can switch to the other mode. So these are the modes, these are the color payloads, these are the status payload, these are the locator. So the in VLSI design styles, the foremost basic is in the layout editor. We have the first advancement means you can able to fix the colors. For example, in the last semester you have studied the VLSI design course, where we use the different types of colors for N diffusion, like P diffusion, okay, polysilicon. We can where we have fixed so few colors only: green, yellow, okay. But metal is also a different two metals we have used. Depending upon the design, you can choose the more metals. If we have more metals means whichever is having the last will have the less resistance. If you have M1, M2, M3 up to M9, M9 metal 9 will have the least resistance compared to the metal 1 to the metal 8. So the common digital cells which with the corresponding truth tables and or inverter and NAND or logic gates. So if you see the simple, can anyone tell me what is this particular gate? This is a reflection question. So while seeing the slide, you can just identify that this is a NAND gate. So NAND gate comprising of two PMOS transistors on pull up and two NMOS transistors on pull down network. If you see how many metals we have used, only one metal. I also quoted the color. This is metal contacts, N diffusion as well as P diffusion. The same this particular design we are converting into this is the integral part of a 1000 or 10,000 transistors. This integral cell will be a submicron cell for our design. So these all green line, blue indicates that these are the different cells. You can identify how many number of cells will be there in our design. It is more than 10,000 to 1 lakh cells. So another two design perspectives we are discussing is, one is feed through cell, and another is over the cell. Feed through means we have to give the space between the routing. This is feed through. Whereas feed over the cell means we have not yet allocated any space in between them for the routing of these cells. Just one over the other you can route. This is over the cell concept. And this is the layout for a micro cell, which consisting of a standard block. I can quote you what is a standard block. A standard cell block means will have a constant heights. Heights are fixed. You can vary the width, but height is fixed. The cells is called standard cells. So this is the feed program logical design. You know, this is the switching box as well as its connections. So I already said what we have studied in the last semester, that our VLSI layouts, we have used only two layers, but depending upon the complex we have not gone through the different metals. You can use any other colors also. So we have used two metals. This is a inverter cell. Can you identify this inverter cell, which consisting of, this is drain and source. These are the external connections. This is polysilicon crossover this one. Then this is PMOS transistor. This is NMOS transistor. PMOS, NMOS. So inverter, one PMOS, one NMOS. Then with the external connections. So what are the layout layers and design rules? First we have size rules, separation rules, and overlap. What are the size rules? Minimum lambda rules, minimum width rules. What is separation? Minimum separation between. And what is overlap means with how much overlap with our design can withstand. So here these are the minimum separation, the lambda based. So minimum separation is lambda. You can see it is a AVs here. These are examples. Similarly, if you have the constraints with the overlap, this is the minimum overlap is of E, and the separation is also lambda. Everything is be considered with respect to the lambda. What is lambda mean? The smallest meaningful technology depending upon the unit of length. Suppose if it is a 90 nanometer technology. So what is 19? The minimum. So that future size is half of our technology. So 45. So what are the physical design optimizations? We have three different types of optimizations. Those three different types of optimization are technology constraints, electrical constraints, and geometrical constraints. Technology constraints is depending upon the minimum layout, that is the using of the technology node. Electrical constraints depends upon the timing the signal delays and staying below the maximum coupling capacitances. And the geometry constraints are included to reduce the overall complexity of the design process, that is preferred wiring directions during the ride.